What is Python's exception hierarchy for error handling? Imagine trying to fix a broken appliance without knowing what kind of problem it has. Understanding Python's exception hierarchy is like knowing the different parts of that appliance. It helps you identify and fix errors more efficiently. Python organizes its error classes in a tree-like structure, starting with a very broad class called BaseException. Every error you see in Python is either an instance of BaseException or one of its subclasses. This setup makes it easier to catch specific errors or handle many errors at once. The top of the hierarchy is BaseException, which includes all errors and system signals. But most of the time, you won't catch BaseException directly because it includes things like SystemExit signals that should usually be allowed to stop the program. The next level down is the class called Exception, which is the main class for most errors you will want to handle. When you write except exception, you catch most common errors like ValueError or IndexError. Other errors that are directly under BaseException include SystemExit, which happens when the program is told to close, and KeyboardInterrupt, which occurs when you press Ctrl+C to stop the program. There is also GeneratorExit, which is used when a generator is closed. The majority of errors you will handle are subclasses of exception. These include errors like ZeroDivisionError, which happens when you divide by 0, and KeyError, which occurs when a dictionary key isn't found. There are also more specific errors like overflow error or type error, which tell you exactly what went wrong. In recent Python versions, a new feature called exception groups was added. These allow you to handle multiple errors at the same time, especially useful when working with asynchronous code. When debugging, understanding this hierarchy helps you decide how broad or specific your error handling should be. Catching exception is common because it covers most errors without stopping system signals. But catching specific errors like ValueError or IndexError gives you more control over fixing particular issues. You can also create your own custom errors by making subclasses of exception. This way, your code can raise and catch errors that are unique to your program. Knowing this hierarchy helps you write clearer, more effective error handling code. It makes debugging easier because you can target the exact errors you want to fix. So, mastering Python's exception hierarchy is a key step toward becoming a better programmer and debugging more efficiently.